What?
All right, thank you for joining us today. I want to talk about data for business growth. Before we dive in, I do want to say if you have any questions, I love questions, so please ask them, type them into the Q&A section, and we will get to those. There's a few breaks in the presentation where we can answer those questions. So as they come up, please type them in. There's a slight delay on the webinar, so it's important to get your question in as soon as it comes to mind for you. My name is Olivier Aubin, and I've worked as a software developer for about 20 years now. And over the last decade, I've gone much deeper into data and machine learning. I've also an entrepreneur, have a startup, instructor occasionally at the university here, and mentor a lot of students and others in the business space. So today I want to talk about how to bring the lessons of data into your business to help you grow. Over the last, I would say maybe decade, we've seen a lot of disruption in traditional industries. Now, you may recognize from these icons the different places, right? We have the taxi services, the logistics, advertising. A lot of these industries, these new companies, have disrupted existing players, in part because of their embracing of data and the new technology. What we want to look at today is how is this possible? How to make this work for your business? If we think about a taxi service, traditionally you would phone in and you ask for a taxi and they're being dispatched often from a central location. In the modern world, we can predict demand. If we look at our data historically, which day of the week it is, if there's a particular sports game happening, we can predict where people may be demanding taxis, or in our case, ride sharing. Very similar concept. And so we could, with good data, be able to understand where the demand will be and position those vehicles. In the space of advertising, if we can understand our users and what they're searching for in more depth, then we can have more relevant ads that both serve the user. They see things that are more relevant to what is on their mind. And we don't have to do the traditional broadcast advertising where it's either very generic or we just blast it out hoping to reach some people within our target audience. The same with accommodations. Do we know what people are looking for? How do we match them to the best accommodations that we have available? And so we'll dive in here a little bit, some of these concepts of how this data came to play in these particular industries. So when we talk about data, I like to qualify it as being intentional data. It's a data we talk about as a business. For a website, and maybe username and passwords, user demographics, and any content that the user generates, data we have, our products that are for offer, our inventory. This is data that every business talks about and they believe that is core to their business. And so this is what is intentional. And I separate this from the implicit data. I call it implicit because the data exists. It's just not something that's talked about or captured in a way that is usable. So how a user interacts with your website, what they view, which products they're interested in, what they click on, how long they spend on a given page, all of these patterns of behavior represent the implicit data. A lot of times this may be captured as part of your server logs, right? The URL they clicked on, or a page view, or a request they send in. In a distributed system where you have many web servers, these logs are scattered about and they're not easy to process. So the data may exist in some forms, but it's often not data that we're talking about in the business and how we can use that particular data. So I'm going to consider an example that we'll come back to a little bit throughout this talk. Let's consider an online grocery store, and their goal is to increase revenue. So they want to meet the user demand, they want to recommend better products, they want to really engage with the users and help deliver a better service. So if we think about our data in this context of this example, it's very easy for us to identify the intentional data. This is our user identity, the person who's doing the shopping, which items they purchased, what is a shipping address, their payment methods. These are the things that a traditional system would capture as part of fulfilling the business process. And it's true that your system can function with this intentional data that you are using to deliver that service. The challenge is a lot of times we ignore a rich data set that is implicit in the user's behavior. And so specifically in this example of our grocery store, we look at things like the search terms. We can look at what a user is searching for. What are they interested in? And we can capture those search terms. That may be of interest down the road. We can also look at which products they view but don't purchase. And we could tie those to the search terms. So they search for a product, they view it, but they don't purchase it. But maybe they purchase a different product. That becomes very interesting information to both improve our search results and also to find similar products or be able to recommend products that they're more likely to actually purchase. So in capturing this implicit data, we can look at which products they viewed, how long they viewed a product, what they added to the cart, maybe items they removed from the cart and substituted. We want to capture all of this information so that we can do later analysis. Now, for our online merchant, the specific things you could do with this data, if you capture this user behaviors, the patterns of searches and product views and interactions with your different products, and maybe they flip-flop between two different products that they're interested in. From that, you can actually glean information to do better product recommendations. What are similar products that users compare? And which one do they ultimately purchase? How do you relate that to the original search terms to then have the best product selection? You can also look at items added to the cart and then a cart being abandoned, or it's not completed, or the user's on your site, but they're just not finishing the transaction. There's opportunities maybe for incentives, or if it's a first-time shopper, you can offer a 10% discount to complete the transaction. And from a marketing perspective, if you can understand your users, maybe there are certain demographics or certain stores or physical locations where users search for different types of products. Are you able to stock products that are more relevant to what the user wants? Maybe you can improve your shipping times, having inventory forecast, or where is your inventory? If you have warehouses across the country, if you're able to locate products close to where the user demand may be, you have better shipping times and you have less overhead with products in warehouses that are not going to be serviced. And so these are just a few of the examples that we want to look at in terms of how to capture this data and what is possible to do with it. So I'm going to pause briefly if there are any questions that have made it in so far.
I had one question about certificates. Are there any kind of certificates about this kind of area of expertise?
By certificates, I'm assuming that's a sort of some training courses or other further studies.
Yeah, like certifications.
Certifications, right. Which data capture, I'm not aware of, to be honest. There are many certificates that people can take training in terms of the data analytics, and we'll talk like data science, and not the focus of this talk, but also machine learning. They focus on how to interpret the data, how to use this data. But where I think a lot of things are missing in the industry, and the purpose of this talk is to try and understand what is the data we should capture. And so that I'm not sure that there are certificates per se, other than having awareness. And through improving, we do have some courses to help frame this sort of discussion in a little bit longer context as well. Were there other questions?
That's all so far.
Okay, thank you. So taking this example, what I want to look at is some of the new concepts and how to actually capture this data. How do we, if we're thinking about the implicit data from our business and also the intentional data that we want to capture, what are the new structures that we have to pull that data in and store it in a way that we can use it to generate the data analytics, and the new business results that we're looking for. So there are three concepts that we're going to touch on, and these ones actually are fairly well documented. There are training courses online and elsewhere to dig deeper. And if anyone has further questions on this later, we can chat at the end. Reach out to me as well. I'm happy to dive into more details. But here I want to give a little bit of overview of the three sort of main technology concepts that enable this data collection. So one of them is a shift towards representing a lot of our data as events. There is a tradition, a longer lasting sort of event-driven architecture that's been around for a few decades, where an event occurs and it triggers reactions within the system. So potentially a product is purchased, it triggers an event that I need to refill my inventory of that particular product. That is still a very valid way to look at events. But the more modern approach is to extend that into looking at events representing any sort of action or observation within our system. And so it's about taking the data out of server logs or from other areas or IoT devices, any sort of logistics systems, bringing that data into our main software system. And so in this case, events may represent a page view. So our server log for troubleshooting captures the user requests, and those are kept maybe for a few days. What we want to do is in the web servers, generate an event that says this user viewed this page. Now I'll get to what to do with that event in a moment, but it's really capturing the idea that events can represent almost every change or action taken within the system. So the search terms that a user enters for online merchant, that is an event. It is a search event and with the given terms. The result that we produce to the user is also an event, which is the list of products that were presented to the user. And so all of these back and forth interactions that occur, we want to produce events. Now, if we've shipped a product to a user, the warehouse events that a product was picked from the shelf, a product was boxed, what size of box did we put it in? When was it shipped? What courier service did we use for shipping? When was it actually delivered? All of these would be individual events that we produce into our system. The idea is it gives us a complete picture of everything that is happening throughout the enterprise. Now, I do want to differentiate that events, we'll get to the storage. These are not, we're not saying update a database with all of this at this point. What we want to do conceptually is generate events from all the different parts of our system and understanding as a business, what are all of the different occurrences throughout the system, whether it's with the user, our servers, and even our sort of back-end logistics. And further to this, we can actually capture events from our in our cloud. How many servers are we using? What is the server load? This gives us information about our capacity to service user requests. And so a server could emit events about it's reaching capacity. We need to bring up an extra server. That is also an event. So we want to track all of the user-facing, the back-end, and actually the operational aspects of our system. We want to think of everything there as events. Now, what do we do with the events? Our goal is simply to capture the events. We don't know how we're going to use all of this in the future, right? All these events may not be relevant to delivering a particular business result today. What we want to do is to capture these events. And this is a newer concept, is the data lake. And this is in contrast to structured data, such as relational database or a data warehouse. The data lakes are what people often say unstructured data. They have structure, so I prefer the term uninterpreted data. It's data that we capture from the events, but we're not going to make any assumptions. We're not going to try to interpret that data right now. We're simply going to take the events with all of the raw data that they contain and store it. Now, a data lake usually is sort of they have different collections. You can loosely organize the data. And so in this example here, we have all of the events. Maybe it is all the user page views and product views might be the blue circles. All of those are going to get streamed into a collection of user interactions for a system. And then maybe the yellow triangles would be the logistics, the back end, what is picked off of a shelf in the warehouse, what is being shipped. So we have all our shipping information in a similar structure, kept in one collection. So there is no right or wrong way to do this per se. It's looking as a business. How do we capture these events in a way that we can go and pick out the ones that we need later? So if I want to study user behavior, I want to use the collection of user interactions with our system. If I'm concerned about the efficiency of our logistics and our delivery, I would use the collection, which represents all of the logistics. So there is value in separating the collections to make it reduce the data set that you have to look at for a particular problem. Now, once we have captured all of these events, they are not, as we talked about, they're not part of an event-driven architecture necessarily. You can have an event-driven architecture, but really this is about taking those events, everything happening in our system, and storing it. It's making it available for later. Now, once we've done that, the third major concept is the new forms of data analytics, and these are often cloud-based. There are many frameworks for parallel distributed computing and processing very large data sets. A lot of these frameworks work best with a data lake. Data lakes are not a centralized database, and so it's easy to read the data in parallel. It's easy to go out and pull from many different collections of data across a vast number of servers to be able to process it. You can even do sort of joins across collections, as we're showing here. Maybe I want to pull my user purchases with my logistics information. I want to join that together, and I'm going to produce a new data set or an insight for the business. Now, this modern approach to this data analytics with the event concepts is that we're not trying to do the analytics as the events come in. We're separating the generation of events from the business cases. By capturing all the events, next year I may have a new business problem, or I've got some time and I say, you know what, I want to optimize this part of our business. I can then go back historically and pull all of the relevant events and now produce new insights or new data sets for machine learning, or I can optimize, right? I can look at my logistics and say, okay, our next biggest savings for as a business may be in this area, and I can generate the data I need to do that analysis. Or it could be, I want to add a new product feature. It's on my roadmap. In a year or two, I get to this and I say, I want to improve my product recommendation engine for similar products. I now have this historical data that I can look at and understand empirically what have users considered to be similar products? Where are the users' interests? If they search for one product, what is the next product that they view? Having the data captured is the essential part here, is to make sure that from the beginning, historically, we're storing that data. And I can't emphasize that enough. Many businesses that I've talked to, they have their intentional data, what they consider their core business data, and they want to do some analysis, and they realize they haven't been capturing this historical data. And so starting today, if they say they want to capture that data, they now have to wait to build up that historical data or the volume of data that's needed for good analysis. And so as a business, to enable your analytics, it's about thinking today, what is the data, the events that I want to capture to enable the problems that I want to solve tomorrow, next year, or 3 years from now. So I take another pause if there are any questions that have come up.
No additional questions in the queue.
Okay, we'll carry on. But yes, I would encourage anyone listening, please, if you have any questions at all, even if it's not directly on these particular slides, if it's a little bit broader question around this topic, please fire them into the Q&A and we'll get back to it here in a moment. So look at how do we leverage this technology and what does a roadmap sort of look like as a business? I want to adopt some of these concepts, but where do I start? So I would say the first step is really identifying your sources of implicit data. Look at your business as a whole and say, where is potential data that I want to capture? Where are all of the points where there's any sort of interaction with users, with customers, with our logistics, with vendors? Are there any servers? Any server that is running some code is going to produce some sort of interaction. Thinking through in a roadmap, trying to get a high-level picture of the data within the business would be a first step. Now, what I'm not suggesting is that you capture every possible bit of data within the business, right? We need to be practical and say, where do we start? And so I think, in my mind, it's painting a picture, a broad picture of what data may be useful to capture, and then choosing what is low-hanging fruit. Where's the potential benefit right now? What are easier systems to tap into to generate events? And then over time, maybe you have a roadmap of a year or 2 years to go out to the different systems within your business and put in a hook to generate the events that you want and to start storing them. To make this work, you want to embrace sort of this large-scale unstructured data storage. The data lake is the most common way to do this. And once you set up that structure, it's easy to go to other systems and hook them into it. So if you've adopted, your favorite cloud provider, they have a data lake solution, you decide to create some collections of events there, you've created that structure that you can work with. Now, as you go through your different business areas, you tap into a system, you generate events, and what you want to do is stream those events into that data lake that you've created. And it may sound complex, but a lot of systems you can easily go in and put in the hooks without disrupting your current production system, without changing its existing behavior. You can add a little thing on the side that says, when something occurs, just generate an event and queue it up for the data lake and have it stored. It's non-disruptive, fairly low overhead, but you're able to produce those events and push them out of the system. So you're not changing the computational needs, you're not adding extra storage to each server. You're just on the fly, just firing events out to go into the data lake. Now, where I think a lot of businesses struggle a little bit with this concept is accepting uncertainty. We're capturing data, but I'm not sure exactly how to structure it. Or I'm not sure how I'm going to need it next year to answer a particular business problem. And so I would strongly encourage you to think through, get past this idea that I have to control exactly the structure of this data, or I have to justify the business value today for every bit that I'm storing. And I accept that it can be a little bit of a challenge to sell to your executive team, but it is definitely the core of this is to say, yes, this data has the potential. These interactions will help us build a better product. Our logistics information will help us reduce our costs and get a better service to our users. All this has the potential to accelerate your business, but to get that value for your business, you have to be storing that data for a period of time to be able to do the analysis on it. Now, as you think through the storage, again, it's planning for future flexibility. I don't know how I want to use the data later. I don't know which business question that I want to answer 1 year or 2 years down the road. And so in capturing the data, it's really bringing this implicit data and its metadata, such as the time that the event was generated, which system generated that event, all of that plus the actual information about the interaction, just capture it. Don't worry too much about the exact format or how it's structured. Generate that data into an event, store it in the data lake. That gives you effectively, it's similar to what you talk about as an audit trail, but it gives you sort of a historical interaction in your system and actually a way for you to be able to replay what is happening. And so you can do some very interesting modeling by recreating your system state at different points in time, or looking at the events, the interactions, or deriving new statistics in the future. Even based on the metadata of the events, when the events were generated, you can look at the time differences between events. And I've done this in the advertising space, where we're looking what are users searching for? How long did they spend on a page? If they spent 5 seconds on a link they clicked on and they came back, that's a very different outcome than if they spend a minute on a page. So the quality of what they're clicking on, if they spend a minute looking at something, it is probably quality. It is relevant content for the user. If they're back in 5 seconds, they probably looked at it, nope, this is not good, and they moved on to something else. So being able to answer these types of questions really means that you have to capture all of this data initially without necessarily knowing how it's going to be used. Now, a bit of a word of caution. I've heard different clients and other folks I've worked with who've come up with these kind of quotes that I said, right? I'm working through my data strategy and I'm going to have all my data collected in 12 months. To me, that is a smell. That is something that's a little bit off. It doesn't sit right. The collecting data in this way with events is not a massive project on its own. It's about freeing the data from the different silos, getting the data out from the different systems that have it stored in like server logs, or maybe it's not even stored, it's just the thing, ephemeral data that just from the user interactions. So trying to do this massive organization of data and structuring it in a sort of massive data warehouse is not the right approach. We want to keep an agile approach, iterative, where it's fairly lightweight. Get those events out of the systems, pull them in, and store them. Don't worry too much again about how it's going to be used. So you don't want to structure your data right now. In a similar thought, some people say, well, I need a relational model for this data. How do I relate this user query? How do I store it in a structured table with my logistics data? Again, not the right approach. You don't want to try and relate all of this data directly. You don't want it in a structured format that way, which confines what you're storing. Now, once you think about this in a relational model, you have to define the structure of the data, the relationship between them, the exact column, the data types. Whereas events are often stored as JSON objects. It's kind of loosely formatted. Not every event is going to have every field. You don't have to worry about having a robust model. You simply just want to store all the data you have right now on the assumption you will be able to go through that data and interpret it later. Now, this last quote is fairly common for most businesses. Now, having worked at Google, we do things on a totally different scale. And so to me, I see the possibility of storing vast amount of data. Now, for a smaller business, a lot of them say, I can't possibly capture all of that data. I would say that's another smell. If you look at the cost of storage, it is very cheap. We're talking about a few $100s a year per terabyte of data. I have an article on our Improving site actually that does the calculations. How much would it cost to store this data? For example, our delivery trucks. What would be, if we wanted to store their location every 5 minutes, so we understand the routes they're taking, how long they're spending at delivery sites, you could store hundreds of years of data for 10,000 truck fleet within a terabyte. That's how cheap, how little storage you actually need. And that terabyte is costing you a few $100s per year. That would be, if you can optimize, that's your gas savings for a single truck, let alone your fleet of 10,000 trucks. And so I think it's really important to look at the trade-offs for the business. What is the actual cost of storing that data in a data lake? Now, relational models, traditional databases are much more expensive to run. The idea with the data lake is you're not making assumptions about the structure. It is a very low-cost storage. And so it's going through, doing the math and figuring out, okay, if I'm storing these events, what's the volume of events that I'm getting out of these systems? And if you work it through, you'll realize that it's not very expensive. It's maybe in the orders of hundreds, thousands of dollars for a particular data stream to be stored. The potential savings to a business, one of our clients, they're easily, for small projects, they're into the millions of dollars of savings. And so the ROI is huge if you're able to capture that data and think ahead to be able to store it historically. So my final thought on this, and it's just a reminder, and I think I've come back to this a few times through the talk, is you don't want to impose any assumptions you make today on your data. And this takes different forms. It's saying, do I need this data or do I not need this data? If it is your delivery trucks, do you know their locations throughout the day? Where are they doing deliveries? you store that data. A lot of times you say, well, it was delivered, the items were delivered. It doesn't matter how the truck got there. What I'm saying is don't assume that it doesn't matter. There's lots of interesting analysis, optimization you can do, fuel efficiency that you can gain from having that data and being to analyze it. So making an assumption that today's business does not need it hampers you in the future. And so it's really about getting past today's assumptions of how you might use that data. And there are cases where you may not have thought of how to use the data later. You might capture the data, I haven't really thought about it. But next year, you're gonna have some ideas, or the whole ecosystem evolves and you're like, there's really an opportunity there. You don't want to be kicking yourself a year later saying, I didn't capture that data. And the same kind of assumptions happen on relational databases. Relational databases are about making assumptions about the structure of that data. Avoid doing that. Capture as much of the raw data in its original format as you can. It'll be there, it'll be available for later, and your business will thank you a year, 2 years down the road when you're able to use that data and answer really interesting questions for the business, be able to optimize parts of the business, better user engagement, and continuing to grow your business. So I want to check in if there's any questions that have come up.
Had one show up. It says, how do you identify the key performance indicators that you might use in the future? Like, how do you innovate to make sure you're capturing the right information so it'll be ready when you need it?
Okay, so the key performance indicators, I think that's one of the challenges is getting past trying to define those performance indicators today for where your business is going to be necessarily in a year based on this particular data. Now you might say we want to grow a revenue for like our online retailer. You may not know exactly how to do that, and you'll have to experiment with different approaches to engage with your users, maybe better product recommendations to hit your goals 1 year, 2 years down the road. The capturing the data, and that's the challenge. Making an assumption based on today's KPIs kind of limits you in the data you want to capture. And really the core of this is getting past and trying to say, having the foresight to say, I may not know what the KPIs are going to be a year or 2 years down the road, but it's looking at your whole system and saying, where are all of the different interactions that occur for our business, our users, our logistics, our warehouse, our vendors, all of these things is mapping it out and saying, we're going to capture that data. Even if I don't have a specific KPI or a particular goal in mind to use that data, it's about being able to capture that. Now, you may not have to do everything. It could become a large project to map out an entire business, especially for much larger enterprises. My suggestion there would be to start in where you have areas. So as a business, maybe some businesses, from the executive level, saying we want to optimize, we want to reduce our costs and optimize the efficiency of a particular area in the business. If that's your driving factor, then I would look in that area of your logistics, your inventory, things like that, of what is data that would be relevant to achieve those particular goals, and start with that data. Start capturing it, start modeling it as events and storing it so that you can do analytics. Now, you don't have to wait 1 or 2 years to do those analytics. You can actually do, capture some data in a month, look at the data, make sure you're getting some interesting insights. Now, over time, as you get more empirical data, you get better insights, but you can start modeling that fairly soon to validate that you're capturing information and that you're using it to drive your business. If you're, different areas, maybe it's a product optimization, maybe you are, as a business, you're fairly cost efficient in delivering the service. Perhaps you just want to engage with the wider user audience. Maybe those your KPIs are around growing your user segments. Maybe I would focus in this case on capturing data for user behaviors, or maybe it's the user demographics. You're trying to target another user segment. Can you capture data for how different user segments are currently interacting with the system and adapt your product to more focused to the next user group that you want to bring on board? So You can look at today's KPIs to help guide sort of the areas where you want to capture data. What you don't want to be constrained on is capturing data only to meet the KPIs you have today. And it's really about looking to the future to say if we have new business problems, or the business maybe shifts direction a little bit, or we meet today's KPIs, but we're going to get new ones next year. Do we have the data to position ourselves to grow? And my experience working in this data space for some very large and some smaller companies, is the benefit we got was the foresight that somebody had, in one case 18 years ago, to start capturing all of these interactions with their product searches. When I look back, I say I can go back 18 years. There's a wealth of data there. At the time, 18 years ago, there's no way they would have predicted the insights we could get today, or that machine learning would be growing as it is today, and that we could use it for more interesting analysis. And so I really have to thank those people who made a decision decades ago to capture that data. And so really to distill down the lessons here is to say, really think about yourself 5 or even 10 years down the road. What is it that you would want to do today that you will be grateful for down the road in capturing that data, and be able to capture the interesting elements of your system to enable those insights later on? Any further questions?
Yeah, got a couple more.
Okay.
The next one is, would properly cataloging the raw data and the metadata be significant cost versus the cost of just storing it?
The question on cataloging the data. Now, at a high level, you have to catalog your data to some extent. You have to know that you have this collection in the data lake that came from the system. It represents this type of data, but that's a fairly low overhead in terms of, I'm not talking about having an index of every single data point, because that becomes massive, right? You might have, for a larger website, 1 billion user interactions. You don't necessarily want to index that ahead of time, but you want to know that I have this collection of data, which is all of the page views on my website. And you can have some stats. Maybe we have 1 billion page views that are stored. I would go to that extent to cataloging it as a business to know where to look for the different collections of events that you have stored. Part of it being unstructured is that you're not worrying about indexing the data right now. When we talk about the data analytics side of it, it's what we do is we actually reprocess that entire collection of events. If I'm interested about patterns with page views, I'm not worried about an index up front that says these are the events that are relevant. The technique there is to actually say, I'm going to point my data processing system, typically in the cloud, like a parallel system, point it at this collection of events, and you define the logic for that particular analysis to say these are the events that are relevant that I'm interested in. And so you may pull in, let's say, 1 billion events that you're going to process. Maybe there's 50 million that are actually interesting. Now you're going, there's a bit of waste in that overhead. Yes, there is a little bit, but the benefit of being able to process that entire collection of events is I define the logic in the future for a particular problem. I decide which events are relevant for that particular question I want to ask. I'm not making the assumptions today. Making too much of a catalog now is baking in an assumption about which specific events might be useful. And so, yes, cataloging at a high level to know what types of events you have, where they're stored, maybe what format, a little bit of information of where it came from is helpful. Having a complete index of all of the events, I would shy away from, because that's starting to move into that structured data, which is not what we're trying to capture here. You had to mention
That kind of leads me into the next question a little bit, and it says, if a company can afford to capture and store all of the data now, is there any reason to not collect all of it?
Yes, absolutely. If you can afford to, and you're able to map out as a business all of the different interactions with the system and start capturing them, do that. I would say yes, absolutely. I think that's a lot of the talk was to the extent that you can. Now, a very large enterprise may struggle to round up all of this data and understand all the parts, but as much as you can, yes, go out to the different parts of the system, even if you don't have a specific KPI in that area today. to the extent you can, go out and find all of your system, map them out, and put in some hooks to generate events from all the systems. Again, do that. Once you find all of these systems, I would encourage you to look at what is the event, on average, how big is a single event? How many events would be produced by that system over the course of 1 year? And then work out the math to see what is the cost. And if it makes sense as a business, absolutely do that. One slight follow-up to that, I don't want to get too far into the technical details, but there are a lot of compression and optimization techniques that can be applied to the events themselves to reduce their size. And I've done a lot of this where you have events and you can shrink them to 10% of the original size. So if you're producing huge volumes of data, there's ways to either downsample and compress and things to bring your costs down and make it more reasonable. So there are techniques there for sure, but if you can afford it and you're able to map out your systems, yes, I would encourage you to work through that and capture that data.
All right, got another one. This data collection model enables the organization to store information that may be relevant sometime in the future for analytics. How does this model perform in the case of near real-time reporting? Is it an added cost to be able to collect and aggregate and perform those analytics in a near real-time scenario? For instance, when you have to get some additional resources from another operator to address a temporary shortage, or should you rely on a different reporting mechanism for this kind of example?
Okay, yes, and so the events we talked about here is the storing the events, all of the interactions within your system. There is a longer running architecture, which is the event-driven architecture that I mentioned briefly. We're building on top of that, and so if you have events generated from all of your systems, I've talked about storing them in a data lake for the analytics, but there are many real-time event-driven systems out there that you can use. There are architectures that, like your system producing an event is generally not running it directly to the data lake. And I didn't get into those details today, but there are architectures with large systems that will actually ingest all the events, sort them out, and write them to the proper collections. And so there are these real-time systems you can look at. One of those, for example, like Apache Kafka, can be used in this capacity to pull in events. You can store them, but if you want an event-driven system and say, I can put a filter and say, these particular events are of interest in real time. So maybe an event occurs and your inventory drops low, below some threshold on a particular product. I want that in real time to be able to go and address that need. You can do that with the same concept of events. And so the events we talked about in the very broad sense of actions and observations in your system, it allows you to also then tap into it in real-time event streams. So to some extent, it is an extension of event-driven architectures that have been around for a few decades. And so yes, if you're able to model the events, using the proper backbone within your system, you can tap into any of those, not just for storage, but also in the real-time processing. And I would say events that are used for real-time processing should also be stored. So you make copy of the events for storage and act on it now where it makes sense in your business.
All right, I don't see any more. While we're waiting to see if anyone else has any questions, if anyone watching this is interested in watching the recording or for any of our other national lunch and learns, we post all of these on our YouTube channel, usually early within the next week. So you can just search Improving Enterprises, and I'll post a link in the Q&A chat as well if you're interested in that. And I'm not seeing any other questions pop up.
All right, I guess we can wrap up there. Thanks for tuning in. Feel free to connect with me. I am on LinkedIn. My name is Olivier Aubin. There are two I's in Olivier, just it's not Oliver, it's Olivier. Just be careful with that. Also, feel free to send me an email if you want to connect, you want to chat about this further. For continued learning, on the Improving site, improving.com, there's /training, there's /thoughts, where different articles of all different parts. I've got some data articles, there's other posting about technology and agile, and /virtual-events for this and other future events. Thank you very much.